Hi guys, my name is Arun and welcome to my channel. This series is a series of tutorials on Fortran Programming. Now, in the last two lectures, last two videos, we were looking at how writing a program to solve the trigonometric identities, and in the last video, we just saw a little introduction to GNU Fortran. Well, GNUplot or GNUplot. Well, I will not be delving into Gnuplot because it's a little tangentially coming out of the Fortran tutorials here. Maybe some other time I'll see if I can incorporate a separate tutorials on Gnuplot or not. I'm thinking about it. Well, I can't be sure. I can't give you any promises on that as of now. Anyway, but I did promise you guys that I will tell you guys a few links about how to find resources to to continue with Gnuplot and all. I will let you guys know in a few videos. Anyway, coming back to the tutorials, we'll finish this tutorial today in this session. Now, when we check these out, the last tutorial, this is where we stood, okay, and I found this nice little function, a nice little operation given by using an indexing arrays, okay, to make this entire thing to be done in one shot. See, you can use do loop and individually alter the array, or use this colon operation to index a slide to manipulate the indices of the matrix of an array like this, okay, and go on with it. Like what this function does is it from the values of 0 to n, okay, each value of the indexing is taken care of by this value I, and the I value changes from 0 to n, okay, and for each value of I, this value I into increment will be stored in the according indices given here. Now, so instead of this do loop, this is a little more handy optimized statement which can be considered. Okay, this is fine, but this is even better. Okay, and then we found these values, and let's print them here. We will not save this in files, but rather we'll finish them up. We'll finish them off here. Let's okay, and let's not I don't want to open a file here, so I'll just comment this out so that you guys can use it afterwards. Okay, now to print them on the screen, we'll initially put this value sign. We'll copy this, okay, comma sine to x I minus it's plus cos 2x. This is I plus cos 2x of I. Okay, and now let's repeat this again, and this, as per the identity, the next is secant square x minus tan square x. So this is secant square x minus tan square x, control D, and cosecant square x, if I'm right, yeah, and probably cot square x. Okay, now let's give them different formats, 35, 45. Okay, I'll define these formats here. Okay, 25 format. Okay, in this value of sine square, I don't have to, I'll just copy this here. copy this, I'll paste this here, square x the value of sine square x plus cos square x at x okay at here I'll put the format f 10.4 is f 10.4. okay, I'll just put an AND statement here and value here. Okay, this will be the format. Now let me just copy this, paste this here, and this should be a negative sign, and this is secant square x, and this is tan square x, and this format should be 35, and then if I were to print this again, this should be 45, and this should be cosecant square x, and this should be a negative sign. Okay, I forgot this negative sign here, and this should be cot. And that's it. Now if I were to print this continuously, this will just the printing will go a little haywire. So let's print them one by one. If these formats are not used, it will not throw up any errors, so that doesn't matter as of now. Now let me just raise this terminal up, clear this up, and then Fortran trig underscore ident minus o, and then trig. Okay, no errors so far. Okay, now if I just type this trig, yeah, perfect. Now in the initial value, at the initially we just gave sine square x plus cos square x at this. Now as per this statement goes by, all of the values are at 1. Now let's just slightly modify this. Okay, degrees is let's give a space in front. Okay, let's save this again. Let's look at this again. Trig, I think I didn't this trig, yeah, perfect. Oh yeah, I have to compile this again. I saved it. Yeah, now if I were to trig this, yeah, perfect. Now this is turning out to be nice. Okay, now let's clear this up. Let's put this down, shall we? And now instead of this 25, let's print this one, the next identity. Clear. Okay, next identity is G for this value. It's working fine, hopefully. Yeah, okay, fine. Now if you look at the values, almost at all the places the values are turning out to be fine, except at some singularity points like this. Now the reason is because at this location, the values tend to go to infinity. Else, I don't know if you guys can see this. Except for this point and at 90, this point, everywhere else the values are 1, except these points, because these points are actually singularity points, wherein not singularity, if I were to say undefined points, because the tan value and secant value, they just shoot up a lot, and it's a little difficult to get answers here. It's very difficult to get answers here, and even at answers here. So it's kind of one is you might have some numerical errors, round of errors that might be dominating. So that's the reason you might get this a little different. Okay, so other than that, this works perfectly fine. Now let's print the last statement out. And let's clear this up. Okay, run this and then click the trigger. Trig, and there you have it. Now you're here in this place also you might notice a few issues. Okay, see, sine 0 is 0, but cosine of x at cosine of x at x equal to cosine of 0 is infinity. So the cosine square is also infinity. So this number is actually not defined at all. So we have a nan here, meaning not a number. So but in other places the values are at least a little finite enough that this trigonometric identity is obeyed. That at 180 degrees, this is almost close to 1. Again, this might be because of the numerical errors, the rounding of errors that might happen, and truncation errors that might happen during the calculation of these values. And finally, everywhere else it's 1. So in a way you can say that this function turned out to be really nice. And that's it, and that's all I have for this tutorial, guys. Hope you guys had fun. Hope you guys had learned something from here. Okay, this is turned out to be more of an example of how to use arrays, and you guys, I believe that you guys will be a little more comfortable with formats and arrays and stuff. Okay, by the way, I just forgot to mention. Okay, if you guys go to okay, leave it, it's just one video going on. If I just go to okay, it doesn't matter. Anyway, if you guys go to my if you guys go to my YouTube tutorials, go to this Fortran video page, Fortran playlist, and if you notice, there will be a link. Okay, well, I'll just show you guys the link. Just hold on. Hey guys, welcome back. Now this is actually the tutorials. I'm tutorial playlist where I'm posting all the videos. Now the thing I want you to notice is that in my web page, in this web page, okay, in the playlist page, okay, in the description you have this web link over here. You guys just click this up. Okay, that doesn't matter. You guys just click this up. Okay, you'll go into a Dropbox folder, a public Dropbox folder. Okay, in that, if you go to this public folder, inside there will be this folder called as Fortran programs, and inside all the programs that we did so far, okay, are present in them. This includes the programs that we did using the code blocks, the programs like the programs that we did using Genie, and all the programs over here. Okay, you guys can have a look, and this is easy to download. This is actually a public folders wherein anybody can go and access the files, but they cannot tamper any files. Okay, I've set the permissions such that anybody can go and access the files without any restraint or conditions. Okay, so what you can do is just go to these files and download the folders. I'll update the files every once in a while, so that you guys can have a look at it. And then I promised you guys I'll tell you guys about GNU Fortran stuff. Gnuplot. So what you do is that type Gnuplot, and then a lot of things can show up over here. So click this one, the www.gnuplot.info homepage, and then there is this tutorial pages by from Duke University by somebody named Professor, I think it's a professor named H.P. Gavin. Okay, click this page. Okay, now if you go to this Gnuplot homepage, as of the April 6, 26, 2015, it looks like this. Maybe after some time it might be little different. Okay, there are many user manuals over here. There are like a lot of explanations, tutorials, external links, scripts, frequently asked questions, documentation, demos and downloads over here, and there are a lot of gallery of demos over here which you guys can look at. And there are a lot of user manuals here, like for the version 4.6, for the version 5, and for the upcoming version 5.1. Even for that, the documentation is available. So what you guys can do is just click one of these documentation. Funny, it just got down very quickly. Okay, if you guys look at this documentation is quite extensive. Okay, these guys just literally cover, I think this documentation just literally covers a lot of commands and stuff available in Gnuplot. And if you guys look at it, they start from copyrights, explanations, environment, and everything, and even the functions that are available, mathematical functions that are available inside Gnuplot and all. So if you guys want to have a look at it, you guys should have, those guys, if you want to work with Fortran in close association without any external need for a program, plotting programs and plotting tools, Gnuplot looks fine, very good. And there are a lot of features also which you guys can have a look at. Okay, these are all explanations, and after some time the plots also come into picture, and I found this really informative. And maybe sometime I haven't learned Gnuplot much, so I cannot teach you guys much Gnuplot here, but definitely after you guys learn a little of Fortran, you might find this a little easy. And if you guys especially have some experience in plotting, making some plots and some high level programming languages like MATLAB or Python or some other programming language, you will find the syntax here are very easy to follow, And that's about this page. I think they do provide these two books, but if you ask me, I think this manual is sufficient. But anyway, I haven't seen these books, how good these are. So if you guys want to get a book about it, you can just have a look. But for simple, quick to learn processes, I think the user manual itself is sufficient. That's my opinion. Your personal opinions can vary. Anyway, this is about this, and this is a small tutorial page created by I don't know who. I don't know who created this. By looking at the name, I think it's somebody named Gavin, maybe Professor H.V. Gavin, I suppose. Here they give all the explanations as to how to install and where to download stuff and all. What are the basic functions available? Some plotting syntax and how to plot stuff, and how to give commands in data files like data files. Okay, how to plot them and continue the line in multiple lines. Okay. So there are some customization commands as to which command to use to have which value to be done, and all. And they are also giving some sample demo on how certain values can look like, certain plots can look like, especially, and like something like auto scale and stuff over here. And there's a lot about it, like curve fitting, multiple plots, how to get data from spreadsheet, how to do some spreadsheet like calculations and all. Just too many of them. These are like very good. At least if you guys did not read at least if you guys did not read this page or here, this is like at least a quick starter. I recommend you guys start with this. I recommend you guys start with this, and then you go with the book here, because this itself will, I guess, for many people solve a large number of jobs. So this will be sufficient. This will be like a superset, and this will be like a subset. Which will be sufficient enough. That being said, that's all I have for this tutorial. In the next tutorial, we'll go into two-dimensional arrays and some matrix operations and some index operations and all. And from there, after finishing this, we'll go into functions and subroutines. Okay, thank you guys for watching. See you guys in the next tutorial.